Hi, I am Ankit and welcome to Tribotech. In this video, we will learn how does an explainer basically work in GN. So explainers are like tools which are used to explain the predictions made by GNN models. They convert or they try to convert the black box GNN models into white box ones. So in this video, we will discuss the objective of an explainer. How does an explainer find important substructures, the assumptions or the shortcut of explainers, and how does explainer use the way GNNs work? So we will take the example of GNN explainer, which is a tool to understand how explainers work. So this tool is basically invented by researchers from Department of Computer Science at Stanford University, and they are also associated with robust.ai, and they publish this tool in the form of a research paper titled GNN Explainer Generating Explanations for Graph Neural Networks, and this paper was published in 2019. So the paper is on your screen, right? So what is the objective of an explainer? So the explainer basically identifies important substructures within the graph, right? Now, what is the meaning of important here, right? So, important means that these substructures basically influence model prediction. In the case of GNN explainer, these substructures are subgraphs and node features, right? I hope you are already familiar with GNNs and therefore you know what are subgraphs and node features. So, for example, in this molecular graph, this highlighted region uh, is a subgraph, right? And each node will be having its node features like this. Mm. So, what do we mean by that? This substructure within the graph influence model predictions. Let's understand this. So, if we input the complete graph into the GNN model, so the model will make a prediction, right? Now, what happens is when we input just these important substructures, for example, subgraph or node features into the GNN model, then also it makes the predictions very close to the original prediction, right? When we use complete graph as the input. So that basically implies that we can replace this complete graph with just this short substructure within the graph. So that basically indicates that how significant or important is this subgraph is and how well it influences the model predictions, right? So this is basically the objective of an explainer, that is to identify such important substructures within the graph. Now, how does an explainer find such important substructures? So they basically use something called masks, right? So a mask is just like a filter. If something is important, the mask keeps it, and if something is not important, the mask fades it out. Now, from this illustration, you can see that the masks have hide all the portion of the graph except this portion. So this indicates that this portion is important. Now, to find out important subgraphs, there are graph marks where each edge within the graph gets an importance score, right? So this is some mathematical value which is called mask score, right? And this value is learned over iterations to find out the important subgraph within the graph, right? So during this process, important edges stay and unimportant edges are muted. Now, in GNN Explainer, we try to identify important subgraphs as well as important node features. So for node features, we have feature mask, where the process is just the same, that each feature gets an importance score here, just like edges, and important features stay, whereas unimportant features are muted, right? Now, an explainer may use soft mask. Now, what does that mean is, uh, instead of the values strictly being 1 or 0 for each edge, for example, the values now can be any real value between 0 and 1. And that's why it is called soft, right? So that means a value close to 1 indicates that this edge is very important, and if a value is close to 0, that means it is not important. Now it depends upon the explainer, right? It is the choice of explainer whether it wants to use soft mask or not. For example, GNN explainers basically use soft mask, but there are other explainer tools also available which do not use soft mask, right? The benefit of soft mask is that since the importance scores are continuous values between 0 and 1, so that means we can compute the gradients, and that leads to computational smoothness or computational efficiency for the explainers, which is not present if the mask scores are strictly 0 and 1. Right? Now, if you think from explainer's point of view, then in front of an explainer are basically a lot of subgraphs available, among which it has to pick up the important ones, right? And same applies for every other substructure, for example, node features, etc. So to figure out important substructures among a lot of substructures is not computationally possible for explainer, and therefore they use some shortlisting criteria, right? And these shortlisting criteria are basically called assumptions, right? So assumptions is a topic in its own, and I'll make a separate video on that. But the point that I want you to take away from here is that assumptions are relative. Basically, it depends upon the explainer tools. What are the objectives that you want to achieve with your explainer tools? So based upon that, they can use uh, assumptions of their choice, right? There's no hard and fast rule that an explainer tool uh, needs to use this, and this assumption, right? Now, explainers use the way GNNs used to work, right? So if you know about GNNs, then GNNs use neighborhood aggregation, right? Which means that each node gathers information from its neighbors and the neighbors from their neighbors, right? So this information travels along the edges layer by layer. So explainer basically utilizes this behavior, and it traces which paths information flowed through and which neighbors influence the node most, right? And this is how explainers basically identify important edges and important node features, which was their objective, right? So this is it in this video. We discuss explainers in this video. So specifically the objective of an explainer, how does an explainer find important substructures, and what are assumptions, which are basically the shortlisting criteria that explainers use to reduce their computational load. And we also saw that how explainers use the way GNNs work. So I hope you now have a good understanding of what explainers are and how does they work in GNNs. If you have any questions, feel free to leave comments. I'll make more videos regarding different aspects of explainers. in this series. Thank you so much for watching. Wish you all the best.